Hello, I am Gabriele Prattico, a PhD student at Politecnico di Torino and in particular with the Grains Group, and I'm working towards XR for education and training. Today I'll present this work titled Look at it this way, a comparison of metaphors for directing the user's gaze in XR training systems. XRTS, in particular in their automatic form without the need of a human trainer intervention, are becoming more and more popular, moving from the laboratories to the industry's training facility to train their workforces. This includes, for instance, training on maintenance and operation of machinery, and despite their increasing diffusion, there are also training situations which have gone mostly unexplored yet, which is the case of parallax-dependent tasks. These PDTs are a subset of machine tasks in which the operator is required to successfully and or more easily complete the task, not only to look at a specific point of interest, but also to do that from a given observation point. Classic example of that are alignment tasks. These peculiarities pose important challenges, especially for virtual reality training systems, due to their more prominent sandbox nature with respect of mixed reality training systems. And this could induce the user to behave lazy, and hence it could be tricky to induce them assuming uncomfortable poses. Of course, in this task there is an ideal target head pose that a training provisioner would like to teach to their pupils through the VRTS, and therefore this should be considered as a skill to transfer to the trainees. So far in the literature there is a lack of specific techniques to teach PDTs. There are techniques that focuses on full body pose matching regarding of the target point of interest to look at. There are techniques to instruct the user to reach a given location regardless of the head pose, and there are of course many techniques that focus on leading the user attention towards a point of interest, but it is given for granted that the operator would assume the correct head pose looking at the point of interest from the right point of view. But this is not usually the case of training PDTs, since there could be non-obvious head poses to assume due to low affordance provided by the given machinery, or simply because the trainee have no previous knowledge of the task being solved. So in this work, we are proposing 3 metaphors to be used in XRTS to teach PDTs, and evaluating them from a trainer-provisioner perspective. So we firstly defined a testbed to stress the metaphors. That entails a fictional procedure to be taught that is made of 6 PDTs inspired by the literature and by real use cases. And we also implemented a VRTS that can be exploited in 2 modes. A training mode that using a scaffolding system guides the user for each task by activating the metaphor, instructing it via voiceover and mixed reality hints, and providing audio feedback on task completion. The latter feedback is also the only one available in the assessment mode. The 6 tasks were devised following 2 factors. The first is by considering the classification of machines tasks, in which local tasks are tasks that can be performed from the current location with one hand, spatial task in which is necessary to reach another place in the environment before performing the required operation, and finally a body coordinated task that requires the operator to coordinate multiple parts of his body, for instance to operate with both hands simultaneously. These are further differentiated along the interaction dimension, so if the interaction with the machinery is direct, or if the machinery is controlled with a remote controller. The difference between the two is that in the remote case, the operator is not constrained to a given location while performing the task. The first metaphor that we implemented is based on an avatar that is shaded with a Fresnel-like effect. There is also a gaze line to instruct about the gaze and the point of interest. And both avatar and gaze will fade proportionally as the user matches the target head pose. We also implemented a second interface based on Frustum that it's expected to provide higher affordance through a face mask shape, and includes also a gaze line pointer as with the same behavior as in the avatar. Finally, since very popular in the literature, we implemented a video-based interface with a panel that follow the users, and the user can eventually relocate in the space. The video shows just a possible move to reach the target at pause. Then we evaluated these three metaphors in a user study that follows a mixed design. In the first part of the experiment, we devised a between subject design where participants split into three equal-sized groups, and then following the first training with selected metaphors, and then they were tested. We gathered subjective results through questionnaire about the perceived training quality, and also quantitative results by assigning a score through video analysis of the performances. There is also a second part, which is intended to gather human-computer interaction aspects that instead follows a within-subject design. The sample of the study included 15 volunteers aged between 24 and 30 years old, and familiarity with immersive VR was balanced in the sample. First, by looking at the subjective result of training aspects, we can see in blue that the Frustum interface was considered as the best of the three interfaces in some of the occasion, in particular about the clarity and the suitability as a metaphor to teach PDT. It was also considered as the best metaphor to preserve spatial presence and the realism of the experience. A slightly different story is told, however, by the quantitative results, where indeed both the avatar metaphor and the Frustum stood out from the video-based interface, which sometimes falls short of an adequate score. However, no clear winner emerged between the Frustum and the avatar. And the same pattern can be found also from the human-computer interaction analyzed perspectives, where both the Frustum and avatar stood out with respect to the video-based interface, with no clear win between the two. It is finally worth noting that all the three interfaces provide comparable information recall, despite of the fact that the trainee grasped the correct pose. In the future, further validation is required with larger sample size and also entailing a mixed reality training system, and could be of interest to study the metaphors as activated by the human trainer in a remote shared virtual reality training system instead of automatic ones.